There is a small machine somewhere in your home that you almost never think about. You set a temperature, the room obeys. If the air gets too cold, something turns on. Warm air moves across your skin. You pull a blanket over your legs, you make a hot drink. The problem disappears before your body even has time to complain. Now imagine taking all of that away. No heater, no thermometer, no factory, no steel tools, and then imagine looking at a black stone on the ground and realizing something strange. It is metal. Not copper, not bronze, iron. But here's the part that changes the story. Your ancestors probably did not discover iron by digging it out of the ground, they found it falling from the sky. So the question is simple. How did humans go from picking up mysterious pieces of metal from the ground to making the iron tools that changed civilization? It starts with something almost impossible to notice. Look at the dirt. Most of the iron around you is not shiny. It is trapped inside minerals. It is mixed with oxygen. It is buried inside rocks. And that creates a problem. You cannot simply find iron ore, pick it up, and hammer it into a knife. The iron has to be separated from everything holding it hostage. Your ancestors did not know chemistry. They had no periodic table. They did not know what oxygen was. But they knew fire. And fire was about to become much more than warmth. Before that happened, though, nature gave humans a shortcut. Some iron already existed as metal. It came from space. Iron meteorites are pieces of metal left behind by the violent formation of the solar system. They can fall to Earth as enormous masses of iron and nickel. You can hammer them. You can cut them. You can shape them. No smelting required. And archaeologists have found evidence that humans did exactly that. At Gerzeh in northern Egypt, 9 tiny iron beads were buried in 2 graves around 3200 BC. Think about that. These people were working with metal from space. The beads were not crude chunks. The metal had been carefully hammered into thin sheets. Then, those sheets were rolled into tubes. The material was also difficult to work. Meteoritic iron contains nickel. That makes it harder than the copper people were already familiar with. Yet, someone figured it out. Someone learned how hard to strike it. Someone learned when to stop. Someone turned a piece of the sky into jewelry, and the necklace tells you something else. The iron beads appeared alongside lapis lazuli, gold, and carnelian. Iron was precious. It was not ordinary hardware, it was exotic. It was mysterious. It had come from somewhere humans could not reach. Your ancestors did not understand the universe. But they were already touching it, and that was only the beginning. Because meteorites are rare, you cannot build a civilization from falling stars. Eventually, humans had to solve the much harder problem. How do you make iron yourself? This is where things get seriously difficult. Imagine you find a reddish rock. It looks ordinary. Maybe you crush it. Maybe you put it near a fire. Nothing happens. You make the fire hotter. Still nothing useful. You try again. You change the fuel. You change the airflow. You change the shape of the furnace. You make mistakes. Lots of them. Because extracting iron is not like melting wax. Iron does not simply become a puddle when you heat it. The temperatures and chemical conditions needed to produce workable iron are demanding. And ancient metalworkers had no thermometer. They had their eyes, their hands, their experience, their memory. That means the discovery of iron smelting was probably not one dramatic moment. It was a long chain of tiny accidents and deliberate experiments. Someone noticed an unusual lump inside a furnace. Someone hammered it. Someone saw that it behaved differently. Someone tried the same process again, then again. And eventually, knowledge accumulated. This is the part nobody tells you. Human technological breakthroughs rarely arrive as single inventions. They are usually piles of mistakes that finally start working. In Anatolia, archaeologists have found very early iron objects dating back to the 3rd millennium BC. Many of these early objects are thought to have been meteoritic because natural metallic iron is extremely rare on Earth's surface. But much later, the evidence for actual iron production becomes clearer. The beginning of the Iron Age in Anatolia and the Near East is generally placed in the final quarter of the 2nd millennium BC. That is roughly the period when iron stops being a strange luxury and starts becoming a serious technology. The change was enormous, because now the sky was no longer your only source. The ground itself could provide the metal, But there was another problem. Iron was not automatically better than bronze. That sounds strange. Iron became incredibly important later, but early iron was difficult to produce. Its quality could vary. Its production required skill. Bronze was already a mature technology. People knew how to cast it. They knew how to work copper and tin. They knew what good bronze looked like. So why bother with iron? Because iron offered something bronze could not. Its raw material was widespread. Iron-bearing minerals are common. Tin is not, and that matters enormously. A civilization can become vulnerable when one essential ingredient comes from far away. Lose the trade route, lose the mine, lose the supply, lose the metal. Iron eventually offered another path. The metal was difficult to make, but the ingredients were much more widely available. That changed the calculation. And here's the twist. The first iron workers were not replacing bronze overnight. They were learning from bronze. The same communities already knew how to control fire. They knew furnaces, they knew charcoal, they knew hammering. They knew that heat could transform stone and metal. Iron did not appear in a technological vacuum. It arrived on top of thousands of years of metallurgical experience. At Kaman Kalahoyuk in central Anatolia, researchers have identified evidence associated with early iron smelting. The furnace was becoming a laboratory. The blacksmith was becoming an experimental scientist. They just did not call it science. And they learned something incredibly important. You do not need to understand why something works to become extremely good at making it work. That idea is easy to underestimate. You can spend your entire life using a technology whose physics you cannot explain. Your ancestors did exactly that. They learned through repetition, they learned through failure, they passed techniques between generations. And eventually, iron became something humans could control. But controlling iron was still not enough. You had to shape it. This is where your ancestors became surprisingly clever. Imagine a small piece of newly produced iron. It is not a perfect bar. It is a dirty, spongy mass. It contains unwanted material. It needs work. So the smith heats it, then hammers it. Again and again, the hammer does more than shape the metal. It helps squeeze impurities away. The process takes time. It takes strength. It takes judgment. Too cold and the metal can crack. Too hot and you can damage it. Wrong technique, and hours of work disappear. This is not factory production. It is human hands solving a problem one strike at a time. And this is where iron starts becoming personal. A blade is not just metal, it is stored labor. The ore had to be found, the fuel had to be gathered, the furnace had to be built, the fire had to be controlled, the bloom had to be worked, the blade had to be shaped. Every useful piece of iron carries a long chain of decisions. That is why early iron objects could be valuable. Tutankhamun's dagger is one of the most famous examples. The Egyptian king was buried in the 14th century BC with an iron dagger. In 2016, Daniela Comelli and colleagues analyzed the blade using portable X-ray fluorescence. They found about 10.8% nickel and 0.58% cobalt. Those concentrations strongly supported an extraterrestrial, meteoritic origin. Think about the implication. More than 1,000 years after the Gerzeh beads, meteoritic iron could still carry extraordinary value. The sky had become metal, and humans had learned to put it into the hands of a king. But eventually, something even bigger happened. Iron stopped being something you admired. It became something you used. Tools, knives, weapons, pins, agricultural equipment, everyday objects. This transition did not happen everywhere at the same time. It was regional, it was messy, it was slow, and the old story that one mysterious civilization simply invented the Iron Age is far too neat. Archaeological evidence from Anatolia, the Levant, the Aegean, Egypt, and other regions shows different communities experimenting with iron at different times. At Phokia on the western Anatolian coast, evidence of iron refining and smithing has been associated with the early 1st millennium BC. Technology spread through people, through trade, through imitation, through craftsmen, through curiosity, and sometimes through necessity. That is the part that changes how you see the discovery. You probably imagine someone discovering iron. One person, one moment, one brilliant idea. But that is not what happened. There was no single person. There was no single day. There was no ancient inventor standing beside a furnace shouting, "I have discovered iron." There were thousands of hands, thousands of failed attempts, thousands of tiny observations, a bead, a meteorite, a furnace, a lump of metal, a hammer, another experiment, and eventually a blade. That's not one invention. That's humanity learning together. Think about that for a second. The metal in your car, the metal in a bridge, the metal in a knife, the metal in the machines that build your machines. None of it begins with a factory. It begins with someone staring at a strange piece of rock and deciding to hit it. And the most surprising part is that your ancestors were not searching for iron. They were solving immediate problems. They needed better tools. They needed sharper edges. They needed stronger objects. They needed materials they could actually obtain. The question was never, how do we begin the Iron Age? The question was much smaller. Can this strange material be useful? That is how enormous technological revolutions often begin, not with grand plans, with curiosity. And eventually, iron changed the scale of what humans could build. But there is one final twist. The first iron humans used did not come from beneath their feet. It came from above them. The earliest known Egyptian iron beads, around 3200 BC, were made from meteorite metal. Centuries later, people learned to extract iron from earthly ores. They refined it. They hammered it. They improved it. They passed the knowledge forward. The meteorite gave humans the first glimpse. Fire gave them the method. Skill gave them control. And time gave them an industry. That is the real story of iron. Not discovery, transformation. You begin with a rock. Then you find metal. Then you learn to make it. Then you learn to shape it. Then, eventually, you build a world around it. And here's what is strange. You still live inside that world. Think about the object in your hand right now. Maybe it contains iron. Maybe the building around you contains tons of it. Maybe the electricity reaching your room depends on machines made with iron and steel. You barely notice. That is what successful technology does. It disappears. Your ancestors once treated iron from the sky like a treasure. You treat metal as infrastructure. They had to fight for every useful piece. You turn a switch and inherit thousands of years of accumulated knowledge. That should make ordinary objects feel a little different. Because every piece of iron around you carries an ancient story. Someone searched, someone experimented, someone failed, someone remembered, someone taught the next person, and eventually that knowledge reached you. So when you hold a piece of metal tomorrow, remember what you are really holding. Not just iron, a chain of human discoveries, a chain that began with rocks, fire, falling stars, and stubborn curiosity. Your ancestors did not conquer iron in one moment. They learned it one mistake at a time. And somehow, those mistakes reached you.